Okay, so we're going to today talk about inductive and deductive reasoning and kind of the difference between those. So we're going to start off with what a conjecture is. Okay, so a conjecture is an unproven statement that is based on an observation and is always true. Okay, so we're going to start off with inductive reasoning. Inductive reasoning uses a pattern in a specific case and write a conjecture or a rule for a general case. Okay, so what I want you guys to do, I'm going to give you guys a couple of examples. I want you to describe the pattern and find the next two items. And when you guys do that, you just pause the video and then I will show you what the answers are afterwards. So our first example is 20, 19, 17, 14, 10, and then you have to find the next two items as well as what the pattern is. All right, our next example is 2, -3, 5, -7, 11, and then you have to come up with the next pattern. All right, the next one is C, E, G, I, K, okay. And the final one is a picture. Got this right here. And then, excuse my drawings, that. And then continue on. All right, so pause the video so that you guys get what the correct answers are. Okay, so here's the key. Here we're going to start by subtracting 1, then subtract 1 more than the previous time to get the next answer. So subtract 1, subtract 2, subtract 3, subtract 4, subtract 5 to get 5, subtract 6 to get -1. The next one we're going to start at the positive prime numbers, switch the signs, so positive to negative, negative to positive, to the next prime number. Okay, so -13 and 17 are my answers. The next one down here is we're going to start it at a letter in the alphabet, which was C, and then we're going to write down every other letter. So C, D, E, F, G, H, I, J, K, L, M, and O. So that's what we wrote down. All right, the next one is starting with the square. We're going to add a square inside, which they're not super great squares that I drew. So if you didn't catch squares and you did rectangles, that's fine, by using 2 of the original sides. All right, so they should, they're not super great squares. So if you described them as rectangles, that would be all right. Okay, so that's all inductive reasoning. I've got a pattern and then I'm creating some sort of rule for it. Okay, let's talk about deductive reasoning. So deductive reasoning uses facts, definitions, accepted properties. And some conjectures. To form a logical argument. So here we're going to use a rule to make a conclusion. Okay, that's what we think when we do a lot of our like solving and things like that. You're using the rules to get to your final statement, right? What x equals in this situation, all right? It's not going to be kind of more the general. So inductive often takes a pattern in order to get like a general, whereas the deductive uses a rule, right, to make a specific conclusion about a certain circumstance. All right, so we're going to talk about here, we're going to complete the conclusion. So our example, and remember all of these examples, all right, you should either know or you will need to know in the future. So you need to know what an equilateral triangle is. So an equilateral triangle has 3 congruent or even equal measured sides. And then I have a specific example of A, B, and C, which did not draw very equilateral at all. A, B, C. So then I can say then, if this is an equilateral triangle, I can say that AB must be equal to BC, must be equal to CD. Or you could also say that AB is congruent to BC, which is congruent to AC. And all of those should have the segment signs right up above it because it's using the congruent symbol. All right, another example. Angle A is an acute angle. Then, and I want you guys to finish up the statement there. All right, we'll do another one. Max works for a company that pays him $9 an hour. Max works 6 hours. Then you can complete that. So pause that, finish those up. All right, if angle A is an acute angle, then we know that the measure of angle A is between 0 and 90 degrees. Not just less than 90, it also has to be greater than 0, right? So you have that compound inequality. And that's an angle symbol, not a less than. Max works for a company that pays him $9 an hour. He works for 6 hours, then he earns $54. Okay, the last thing we've been talking about is we've actually defined this before, our counter examples. A counter example is a specific example to prove a conjecture false. So, for example, if we have an odd plus an odd, always equals an odd. Is that the case? No. For example, 3 plus 7 equals 10. 10 is even, so that's an example a counterexample that would say that this conjecture is false. Okay? All right, you guys can work on your homework then, and if you have any questions, make sure to let us know.